Welcome all to my YouTube channel. My name is Anand, and today I have the pleasure to teach you some chemistry. It's Chemistry 20 Alberta or grade 11 chemistry. Today we're going to talk about the concept of calculating concentration. So let's discuss these three formulas. C is equals to N over V. When you rearrange it, you can do, if you wanted to find moles, you can do concentration times volume. And if you wanted to find volume, you can do moles over concentration. So concentration is represented by the units of moles per liter, and then N represent moles over volume, and that's how you get moles per liter. So let's take a few examples, and let's see. You won't see it at the moment, but let's take a moment and see how can we do fairly simple, or it can be either fairly simple or fairly difficult questions. And that's what I'm here for you today. I'm here to teach you different ways on how to rearrange equations and finally solve them. So let me just put this question up on the board. Pardon me of the background noises. It's me typing. So the question will be up in a moment. So what I want you to do now is to take a minute, pause my video, and try solving this. Calculate the concentration of a solution that contains 0.67 moles of sodium chloride to form 750 ml of solution. So while I'm doing my working, you guys take a moment and do your working. Check what are the keywords of this question and maybe box them out. So here, as you can see, I boxed a calculate the concentration. So what we are finding is concentration. So let's write that down. I like to do all my working on the left hand side of a solution that contains 0.67 moles. So what did we talk about moles on the last slide? We talked about that moles is represented by N. So you write 0.67 moles. And then finally, when I talked about volume, we said it's always commonly represented in liters. So we must convert the ml to liters. So let's see. So let's do 750.0 divided by 1000 is 0.750 liters. As you can imagine, liters are smaller than milliliters. So now we need to find C. The regular standard formula we use, so C is equals to 0.67 divided by 0.750 liters. Make sure to put your moles and liters units because it will be important for school. So when we do in a calculator, I'm just working it over in a calculator at this time. You can also do that. So 0.67 divided by 0.750, we are looking at 0, so that's giving you a decimal of C is equals to 0.89. Remember, in chemistry, it's always important that you think about the significant digits, and that's important for always. So your final answer is C is equal to 0.89, and how I got the significant digits is looking at 0.67 moles. Now I'm gonna ask you to take a moment, think about these questions, redo the question if it helps, and we'll wait for the second question to pop up soon. Again, always trying different examples, different questions is always key. There are a lot of examples online which can help you. I can also post questions for you if need be. And over my next video, we will go and look into more harder solutions. It's better that you practice always tough ones as well. So now this one. Again, take a moment. I will be doing my working right now. Take a moment, think about what you need to add, pause my video. So now there are again three important things you need to look at here. How many moles? So we are looking to find N. How much is N? Are dissolved in 354 ml. So let's look 354 ml. So we are going to look at 354.0 divided by 1000. 1, 2, 3. So we are looking at 0.354. And we are looking at a concentration of 0.240 moles per liter. So what do we do next? So we need to find, so this is our standard formula. Always go back to your standard formula. What did we discuss on the first slide again? We need to do N is equal to C times V. So when doing C times V, we do 0.354 liters times 0.240 moles per liter. And then we cancel out the else. That's how, that's common mathematics. You need to be already knowing. And then we just multiply. Let's take a calculator out again. 0.354 times 0.240. So you are looking at, how many cyclics do we have? We have 3 cyclics, 3 cyclics. So we are looking at 3 cyclics. So you can put as 0.085 moles. And this is your working. And finally, we'll look at one last question. I don't like to overwhelm you with a lot of questions in a day, so that's why I'm going step by step. I am showing you formulas, and I'll go over like 3 questions per day kind of thing. And thank you for taking the time to watch these videos. It will be really helpful for your days to come up in school. Again, always practicing these questions is a key thing to growing your success with chemistry. So let's again go back to this question. So what volume of a 0.890 moles per liter moles? So we know we need to find volume. So question mark. We know already concentration is 0.890 moles per liter. And mole is 4.8 moles. In this, you wouldn't have to do any conversions, so that's good. So let's get started right away. So when we do the manipulation, we get N is equal to C over V. Now we need V by itself. Let me undo this. Sorry. So when we need V by itself, we do N over C is equals to V. So N is 4.8 moles over 0.890 moles per liter is equals to V. So what do we get as V? Let's find it out. Again, take out a calculator, very helpful. So we are looking at 1 cyclic, 3 cyclic. We are looking at 1 cyclic, 1 after the decimal. So we can look at 5.4 liters. Always remember, include your units at all times. And that's about it. So you might have learned in this concept that there are different ways of rearranging one formula, and that was C is equals to N over V. Let me put this question for you for bonus. You can try that, and I'll leave the answer in the comment below, in my description below, and you can verify if it's correct. So this is a very simple question. I want you to try by yourself, and I'll leave the answer in the description box. So the fourth question, C is equals to 400 moles per liter and volume is 300 liters. Find the, volume is 0.300 liters. Find moles. Again, thank you for joining me on this video. We will see you next time.